In this video, I'm going to talk about simplifying radicals. Radicals are roots. It's another word for root. So I want to simplify square roots or cubed roots or fourth roots. And what it means to simplify them is I don't want to leave inside something for a square root that is a perfect square. Something in a cubed root that's a perfect cube. Or something in a fourth root that's something being raised to the fourth power. So I want to take those things out. If I start with the square root of 24, what I want to take out, since this is the square root, I want to take out the biggest perfect square. I want to take out all the things that are being squared inside, all the factors that are being squared. So I'm going to take out the biggest perfect square. I want to break down 24 into the biggest perfect square times something else. The biggest perfect square inside of 24 is 4. So I'm going to write this as the square root of 4, which is going to give me a whole number, times the square root of 6. 4 times 6 gives me 24. The square root of 4 I know is 2, so really this is 2 square roots of 6. I can't break down the square root of 6 any further. There's no perfect squares inside of 6, so this is my final simplified answer. There's nothing being squared inside there anymore, no factors that are squared. For number 2, if I want to do the square root of 300, x to the 4th power, y to the 7th power, I want to look at all the different kinds of things separately. So I want to look at the numbers separate from the x's, separate from the y's. Looking at the 300 here, I know the biggest perfect square inside of that. Also, I'm taking up biggest perfect squares again because I have the square root. So I'm looking for things that are being squared or perfect squares inside. So the biggest perfect square inside of 300 is 100. I'm going to rewrite the square root of 300 as the square root of 100 times the square root of 3. For x to the 4th power, the biggest perfect square inside of x to the 4th power is x to the 4th power. X to the 4th power is a perfect square. The biggest perfect square inside of y to the 7th power is y to the 6th power. It's an even power. So y to the 6th power, if I take the square root of that, I'm going to cancel out the square root. I'm not going to have a square root anymore. So I have the square root of y to the 6th power, but I have one extra y that needs to be included. So the square root of y. All these things are being multiplied. And then I'm going to simplify all the things that I have in color. So the square root of 100 I know is 10. I can't change the square root of 3. That stays the same. The square root of x to the 4th power is x squared. And the square root of y to the 6th power, that's y to the 6 over 2 power, which is y to the 3rd power. It's y to the 3rd power. And then I can't change that square root of y. I have 10 x squared, y cubed, the square root of 3y. This is my final answer. For 3, I'm going to first multiply these things together. So I'm going to multiply the constants or the coefficients. 3 times 2 gives me 6. And then I'm going to multiply all the things that's inside. 2 times 6 gives me 12. X times x to the 4th power is x to the 5th power. Y squared times y is y cubed. And now I'm going to break this down like I did the last one. So what's inside of the square root, looking at the number, there's a perfect square inside of 12, and that is 4. So I can rewrite this as the square root of 4 times the square root of 3. For x to the 5th power, I can rewrite that as the biggest perfect square inside of x to the 5th power is x to the 4th power, and I can rewrite x to the 5th power as x to the 4th power times x. So it breaks down into the square root of x to the 4th power times the square root of x. And lastly, I have this y cubed. I can break that down into, or the biggest perfect square inside of that is y squared. So I have y squared, square root of that, times, you need to multiply by y to get that y cubed. So now that I've broken everything down like this, I'm going to just change my perfect squares to what they are. So I have 6 times 2 times the square root of 3 times x squared times the square root of x times, that's y, times the square root of y. And then I bring everything together that I can. So 6 times 2 is 12, so I have 12 x squared y on the outside, and then inside of the square root I have 3x and y, so 3xy. This is my final answer. Sometimes I'm going to have things that are not square roots, so maybe I'll have the cubed root. if I have the cubed root of 48, x cubed y to the 6th power, I'm taking out not groups of 2, which is what I was doing in the last thing. I was looking for perfect squares, something being squared. Here I'm taking out groups of 3, so I want perfect cubes. I want to take out perfect cubes. If I don't do it that way, I can take out groups of 3. So I can break down 48 into 2 times 24. 24 breaks down into 2 times 12. 12 is 2 and 6, 2 and 3. So if I were to rewrite this, I could rewrite it as, if I break it down into its smallest factors, everything that's inside, I could write 2 times 2 times 2 times 2 times 3. The x breaks down into, there's 3 x's, and there is 6 y's. 1, 2, 3, 4, 5, 6. I'm taking out a group of 3 2's, so then I can write 2 on the outside when I do that. Cross this out. I can't take, there's no more groups of 3 as far as the constants go, so I move on to the x's. There's a group of 3 x's. I can take that out. Cancel, and then I have a group of 3 y's that I can take out, and another group of 3 y's that I can take out. I'm multiplying these things on the outside. And then left inside of the cubed root, I have 6, and that's it, just 6. So I can erase that. And when I simplify this, it's 2x y squared times the cube root of 6. That's my final answer. And then for number 5, sometimes you're going to see roots on top of each other. If they're the same root, you can actually combine them. So I could rewrite this as the 4th root of 80y to the 7th power over 5y squared. And this way I can cancel things inside and simplify before I do anything else. So I'm going to, I'm going to do 80 divided by 5. That gives me 16, so I have the 4th root of 16, and then y to the 7th power divided by y squared is y to the 7 minus 2 power, or y to the 5th power. That gives me this, and then I'm looking for groups of 4 to take out. So if I break down 16, I can break it into 2 times 8. This breaks down into 2 times 4, 2 times 2. Oh, it's 1, 2, 3, 4 2's. I have 1, 2, 3, 4, 5 y's being multiplied, and I'm doing the 4th root of this, so I'm taking out groups of 4. Here's a group of 4 2's that comes out, and then I have a group of 4 y's that comes out, and I'm left with inside just 1 y. And this is my final simplified answer.